Hello, my name is Danica Dvorchak, and this is a tutorial for problem 3.1.11 in Operations Research and Introduction. This is for my Engineering 340 class at Liberty University. I hope it is helpful. So the prompt for this problem is that the Omega Manufacturing Company has discontinued the production of a certain unprofitable product line. Management is considering devoting excess capacity to one or more of three products. The available capacity on the machines is, and it shows you a table, there's three machine types and there's a certain amount of machine hours available per week. So for example, the milling machine only has 500 machine hours available per week. There's also a lathe and a grinder. The prompt continues saying that the number of machine hours required for each unit of the respective products is, and there's a table for this one as well. So those three machines are labeled here, the milling, the lathe, and the grinder for each of the three products. So for example, each unit for product 1 requires 9 hours on the milling machine, 5 hours on the lathe machine, and 3 hours on the grinder. The prompt continues saying that the sales department has indicated that the sales potential for products 1 and 2 exceed the maximum production rate and that the sales potential for product 3 is 20 units per week. So we could make as much of product 1 and 2 as we want and they would sell, but if we make more than 20 units of product 3, only 20 units would sell, so there's no point in making more than 20 units. In addition, the unit profit would be $50, $20, and $25 respectively for products 1, 2, and 3. The objective is to determine how much of each product the Omega Company should produce in order to maximize its profits. For this problem, we need to A, formulate a linear programming model, and B, use a computer to solve this model by the simplex method. So for part A, this is my linear programming model that I came up with. We see the objective function is to maximize z equal to 50x1 plus 20x2 plus 25x3. The coefficients there, the 50, 20, and 25, that's how much profit we would make per unit of each of those products. So if we remember back to the slide before, it said that we could make $50 for each unit of product 1, $20 for each unit of product 2, and $25 for each unit of product 3. So that's where that objective function is coming from. We also have constraints we need to consider. So each of these constraints has to do with, well, not each of them, the first three have to do with how many hours are available for each machine. So if we remember back to the two tables that we saw in the prompt, we remember that for the milling machine, there was only 500 hours available on that machine per week. We also remember that for product 1, 9 hours were required on the milling machine for each unit. 3 hours were required for each unit of product 2 on the milling machine, and 5 hours were required for each unit of product 3. So the sum of all of those products that we're going to make has to be less than 500 hours. We also have that type of constraint for the lathe machine and the grinder. The final constraint here is that product 3, X3, has to be less than 20. This has to do with that sales potential we talked about earlier, where if we made more than 20 units of product 3, those extra units wouldn't sell. So there's no point in making more than 20 units. So we're saying that we need to make 20 or less units of product 3. Our final constraint here is that products 1, 2, and 3, however many units we make of them, have to be greater than 0. We can't make negative units of any of those products. So that's part A. For part B, we are supposed to solve that linear programming model with a computer. I chose to use the simplex method in the Excel solver. So to do this in Excel, you need to set up a table that looks something like this. You can set it up slightly differently. You can kind of Google different ways to do it. This has kind of been the consistent method that I've seen online, and that was also discussed in the book Operations Research. Basically, the gist here is that these first 4 rows are your constraints for the milling, lathe, and grinder machines, and then the final sales potential. And then the columns 1, 2, and 3 are respective to the products 1, 2, and 3. The unit profit here on the bottom is those coefficients of the objective function, or how much money we can profit per unit of each product. So we can make $50 for each unit, of product 1, $20 for each unit of product 2, and $25 for each unit of product 3. We fill in zeros for the solutions row, but the zeros in the totals row are special. If we were to hover over or click on one of these cells, it would show a function or an equation. And that equation is going to be some product, and you can see this down here in the bottom, some product of that respective row, comma, the solution row. So for example, if we were to say, here, let me get the laser. If we were to say that this column is C, this column is D, and this column is E, and let's say these rows were 5, 6, 7, 8, 9, and 10. This first is 0. The equation here would say equals some product C5 through E5, comma, C10 through E10. That goes all the way down, so this would be C6 through E6, comma, C10 through E10. This would be C7 through E7, comma, C10 through E10. This would be C8 through E8, comma, C10 through E10, and this would be C9 through E9 right here times C10 through E10. This totals 0 at the very bottom here. That's going to give us our grand profit, our total profit. So we want to maximize this number right here. The final thing to be mentioned on this slide is this hours available column over here. And what's happening here is we're going to make a constraint that this total, whatever this comes to, it needs to be less than or equal to the hours available over here. That is it for this page, so we're moving on. This is when you actually would go to click on the solver. In order to get to the solver in Excel, you're going to go up to the Data tab in the top ribbon in Excel. It's going to be over towards the right. I think it's the third to last tab to click on. And in the very far right side of the Data tab, there's going to be Solver in the Analyze section. If Solver is not there, it is because you have not downloaded Solver into Excel, and you need to do a quick Google search to show you how to do that. I'm not going to go through that in this video, but it's a pretty simple procedure. There's lots of tutorials online on how to do that. I believe some of the more recent versions of Excel already come with Solver downloaded. So that's just something to know. If you can't find Solver, it's probably because it's not downloaded. So once we get Solver going, we're going to set the objective here. This cell that has been clicked on, that is the cell that we want to maximize that I pointed out in the previous slide. It's that very last cell in the totals column. Like I said, we want to maximize it, so we're going to click on maximize here. In other problems, you might want to minimize the objective function or find an exact value, so that's why there are other buttons here to click on. But for our problem, we're going to maximize. And we want to do this by changing the variable cells in the solution on the very bottom, the zeros that we had put in. So we're going to say C10 through E10 for that one. In order to make this realistic, though, to our problem, we need to add in those constraints. So this one on the very bottom, it's kind of difficult to read, but what that's saying is that all of the zeros that were underneath the totals column, except for that very last one we're trying to maximize, but those top 4 zeros the values in those need to be less than or equal to the values underneath the hours available column. Once again, I kind of pointed that out in the previous slide. So that's a constraint we have to put in. This top constraint is not necessary, but it makes it more realistic. We can say that we want our solution values to be integers. And when you go in to do that, you're going to click on the middle tab that will say equals or less than or equal to, and there should be something that just says int, and that's just saying that we want each of those solution values to be an integer. Another thing to note is we want to click this box. We say that we want to make the unconstrained variables non-negative. This adds in that last constraint that we talked about, where each of the unit numbers for products 1, 2, and 3 need to be greater than 0. The very last thing we're going to do is click down on this button here, and it gives you like 3 or 4 different options, and we want to click the simplex method since it told us to solve by the simplex, and then we just hit solve. If this was done correctly, you should come out with something like this. The solver changes these zeros in the total, and it changes your zeros over here in the solution, and it gives you this maximized dollar value. So this is saying that if we make 26 units of product 1, 55 units of product 2, 20 units of product 3, we will stay underneath our constraints. So we can kind of double check here. 499 is less than or equal to 500. Yep. 350 is less than or equal to 350. Yep. 118 is less than or equal to 150. And 20 is less than or equal to 20. Yay. So those all check out. And we get a maximized profit of $2,900. I hope this was helpful. If there are any questions, please let me know in the comments below.